Okay, let's look at a couple more examples of the finance formulas and solving for different parts of the equation. So it says if you have $1,000 and can invest it at a 10% interest rate, compounded quarterly, how long will it take your money to double? So this is a pretty commonly asked question, the doubling time of money or the tripling time of money, that kind of thing. Um, so for this example, we actually know that we have $1,000. So we know that our final amount would be twice that, $2,000. But if you don't have the amount of money, if they just say, how long will it take for an amount of money to double, you can just use $1 and $2. It'll be the same as if you did $100 and $200 or $1,000 and $2,000. So just double whatever that initial amount is. So the things that we have here are we know that the initial amount is $1,000, and we know that we want to get A to be $2,000, and we know the rate is 10%, which is 0.10. And then we know compounded quarterly means a quarter, divide the year in quarters. So it's 4 times per year. So n is equal to 4. And I think that's it. And we are looking for how long. So we're going to be finding the time. Okay. So 2,000 equals 1,000. Now, you have to decide which formula to use. Really between the compounding an n times per year or the compounding continuous formula. Don't use the simple interest formula. That's just an introduction. So don't really use that one. So since it says compounded quarterly, we know we have to use the formula with the big parentheses, 1 plus the rate, 0.10, divided by 4, and then raise that to the nt, so 4t. Okay? So as you can see in this problem, we the thing that we're solving for is up in the exponent, okay? So eventually in this problem, we're going to need to use logs to solve this problem because we're solving for the exponent. So we're going to turn it into log form. All right, so the first thing that we should do is get the base by itself, the base raised to the power by itself. So we want to divide both sides by 1,000. Those colors are pretty. So that's 2 is equal to, and then the stuff in this parentheses you can multiply out if you want. 1 plus 0.1 divided by 4 is 1.025, and this is raised to the 4t. Okay, now we're going to turn this into log form to be able to solve. Okay, so we do log, remember the base remains the same, 1.025, and then switch the location of the other two things. So 2 equals 4t. Okay, now the t is easy to solve for because we just put this log into our calculator and divide by 4. That's why we practice so many log equations in the past. So remember, if you have the log base formula in your calculator, you go to math and then hit up, and you'll see it. Otherwise, you use the change of base formula. So you would type log 2 divided by log 1.025. Either way is fine. That will give you the same number. And then divide that number by 4. You'll get about 7.02 years. Okay. So try that and make sure that you can get that in your calculator, okay? All right. Next, how long will it take for a lump sum of money to triple? Triple if the interest rate is 6.5% compounded continuously. Okay, so this time we know we're going to use the continuous formula. A equals PE to the RT. And we want our money to triple. So in other words, our A is going to be 3 times our P. Okay, again, this is the same thing. You can use 300 and 100. You could use 3,000 and 1,000. The result will be the same as if you use $3 for the final and $1 for the initial amount. And then our rate is 0.065. Okay, so let's plug those in. 3 equals 1e to the 0.065 t. Oh, sorry. Again, we're finding t because it says how long. All right. So to solve this one, we're going to divide both sides by the 1. So that's 3 equals e to the 0.065 t. Now we're going to need to change it into ln form. It's log form, but for natural logs, for e. So that would be ln of, and remember e is the base, so you don't have to write that, and then switch the other two places. Ln of 3 is equal to 0.065 t. Okay, and then to solve for t, just divide both sides by 0.065. So you can type natural log 3 into your calculator and then divide it by 0.065. You'll get t is about 16.9 years. Okay.